Hello students, I am Shatabdi Acharya from Vedang Institute of Technology. In this video, we will be dealing with formal charge. So first let us understand what exactly is formal charge. It is the difference between the number of valence electrons in an isolated atom and the number of electrons assigned to that atom in the Lewis dot structure. Okay, so it's basically the difference between the valence electrons and in a bonded state what are the electrons around the atom. So basically we know the molecule as a whole is neutral. Okay, the entire molecule as a whole is neutral, but if the charges, suppose in case of ions, the charge carried by the ion for the ion is for the ion as a whole and not for the individual atom, individual involving atoms, right? So formal charge is that charge, it does not adds up to the entire charge of the molecule, but what exactly are the charges of the individual atoms in the molecular or bonded state, that is defined as formal charge. It does not indicate the real charge separation within the molecule. It's just calculated to know the charges the one particular atom is having in that bonded state. We'll understand it better if we consider this example, ozone. Okay, so first let us understand the formula for formal charge. So formal charge equals to total number of valence electrons minus total number of lone pair electrons minus half of total number of bonding electrons or bond pair electrons. Okay, so why we are taking half for bonding electrons? Because in the bonded state the electrons are belonging to both the atoms, right? It's not the contribution of that one particular atom. Therefore we have the formula for formal charge. It is formal charge of any atom. Okay, for single atom the formula is total number of valence electron minus total number of lone pair electrons minus half of total number of bonding or bond pair electrons. So if I consider ozone, the structure of ozone is given as follows. It is basically the Lewis dot structure of ozone. Now if I number the carbon 1, 2, 3. So formal charge for the first oxygen 1. The total number of valence electrons around the oxygen is 6 minus the total number of lone pair of electrons. So oxygen in this state is having 2 lone pairs, that is 4 electrons. So 6 minus 4 minus half of bond pair electrons. So there are 2 bonds, 4 number of bond pair electrons, half of that is 2. So 6 minus 6 is 0. So here this oxygen atom is in 0 formal charge. If I consider oxygen 2, second oxygen, again the valence electron is same, 6 minus lone pair electrons 2 in this case minus half of bond pair. So here half bond pairs are 3, 1, 2 and 3. So total 6 electrons, half of 6 is 3. So you get 6 minus 2 minus 3, which is plus 1. So for oxygen the formal charge is plus 1. For the third oxygen O3, the formal charge here is valence electron 6 minus lone pair 1, 2, 3, 4, 5, 6 minus half of bond pair. Here one bond is there, so half of 2, it is 6 minus 1, it is having minus 1 formal charge. Now you see this plus minus and plus 1 and minus 1 cancel out each other and ozone molecule turns out to be neutral. Okay, so this is how we calculate the formal charge in an atom. Now what are the advantages of calculating the formal charge of an atom, right? So a particular molecule can be, if we consider Lewis dot structure, a particular molecule can be represented by n number of structures, right? For there are different structures for different molecule, but which one will be the most contributing structure, which one will be the most stable structure, or which is the actual or most correct structure of that molecule, that is determined by formal charge. Okay, the molecule, and always remember, the central atom always tries or always wants to be in a zero formal charge. Okay, and the negative charges are always belonging to the corner atoms, and positive charge mostly belongs to the central atom. Okay, so the structure where the formal charge is minimum, that is considered to be the most stable structure or the most appropriate structure for any molecule. So formal charge basically helps us to find out which structure is the correct structure or the correct representation of that molecule. Now we have understood what is formal charge, we understood what is octate rule, but there are certain limitations to the octate rule. So in this video, we will be dealing with the limitations of octate rule. The first limitation is, okay, the octate rule said atoms belonging to group 1, 2 and 3. Okay, group 1, 2 and 3. They have 1, 2 and 3 as their outermost shell electrons. Okay, so it said basically the electron or the atoms belonging to these groups can only form ionic bond because they can only lose electrons, okay, to form cations. They cannot share electrons because they are having less than 4 in their outermost shell. So therefore these groups cannot form covalent bond. But actually what it was observed is there are certain elements or atoms like Li, Be, again beryllium, they form structures of LiCl, BeF2, BeCl3, FeCl3, AlCl3, etc. What happens here? If you see LiCl, how many number of electrons are there around lithium? Only 2. So lithium is having less than 8. Okay, they do not satisfy the octate rule because here the outermost electronic configuration is not 8. Here lithium forms 2 outermost electronic configuration. Here BeF2, again beryllium is having 4 electrons in its vicinity because 2 bonds. 2 bonds with fluorine, therefore 4 electrons. Here BeCl3 is having 6 electrons. FeCl3 is having 6 electrons, AlCl3 is again having 6 electrons. So basically they do not satisfy the octate rule, or they are forming elements or they are forming compounds which are electron deficient. Okay, electron deficient, and these category of compounds are called as Lewis acids. Why Lewis acid? Because according to Lewis, acids, Lewis gave the definition of acid as those compounds or those substances which have the tendency to accept electrons. So now they are electron deficient species. They obviously have the tendency, as per octate rule, to gain electrons to satisfy their octates. Therefore, these electron deficient atoms are called as Lewis acids. Now if we move on to the second limitation, formation of superoctate. Okay, there what in the earlier limitation what we learnt, the compounds having less than 8 electrons, okay, electron deficient. Now these are electron excess. Which compounds will have electron excess? So remember students, in the video we learnt, like in the previous video somewhere we learnt why PCl5 is possible but NCl5 is not possible. Why? Because of the presence of d electrons in PCl5 and N was lacking d electrons. So the compounds where there is presence of or there is a chance of presence of d electrons, then what they can do, they can basically expand their octate beyond the set orbital. Okay, they have the tendency to expand their octate. So they can basically form bonds more than, or they can basically acquire electrons around them more than 8. They form superoctates. More than octates, so superoctates. And what are such kind of atoms? Obviously those are having d electrons, and d electrons are starting from 3 or the third shell. So third period and beyond. The elements present in the third period and beyond the third period have the tendency to form superoctates. Okay. If we take the example PF5 here, phosphorus is the central atom and around phosphorus 5 fluorine bonds are there. That means 10 electrons are there, obviously more than 8. In case of SF6, 12 electrons around it, IF7, 14 electrons around iodine, and you will see this very evident in many coordinate compounds, which you will be learning in the further lectures. In the chapter coordinate compounds, you will see majority of the coordinate compounds, they do not obey the octate rule. Okay, the next is formation of compounds of xenon and krypton. Okay, what we have studied basically in the periodic table, we have a group 18 elements, right? The elements which are called as noble gases. Why they are called noble gases? We have learned so much about them. We had heard so much about them in the octate rule, right? Every atom tries to occupy 8 electrons in their outermost shell. They have to undergo the electronic configuration of their nearest noble gas. So what is this noble gas? Noble means unreactive. Why they are unreactive? Because they have 8 electrons in their outermost shell. So basically xenon and krypton belong to those category of noble gases. As per rule, they shouldn't be that reactive. But what happens when under drastic conditions? Okay, not under normal conditions, but when the conditions are drastic, for example high temperature, pressure, or example in the presence of very high or very electronegative elements like fluorine and oxygen, they are bound to form certain compounds like XeF2, krypton KrF2, XeOF2, XeOF4, XeO2F2, etc. Okay, so this is also a limitation of octate rule, where it deviates the concept that noble gases are unreactive. Under drastic conditions, various noble gases of xenon and krypton, they form various compounds with oxygen and fluorine. Next is formation of odd electron molecule. What we knew from octate rule, again it has to, the element or the atom has to acquire 8 electrons in its around itself in order to be stable. But if you observe the structure of NO, okay, oxygen is having 2 lone pair, nitrogen is having 1 lone pair, but an unpaired electron. This is the structure of NO. But octate rule did not suggest anything about odd electron species. So this is also one of the limitation of octate rule. Lastly, it gives no information about the shapes of the molecules. It just gives the information about the structures, like how it is bonded, how the lone pairs are present, and how the atoms or the corner atoms are present around the central atom, but it did not give any information about the shape of the molecules. Okay, so in this video we are officially ending the types of bond like ionic bond and covalent bond. From the next video we will be studying about certain bond parameters like what is bond length, bond strength, and what is bond angle. Then we will move up to various important theories explaining the structure of molecules. First of it is valence bond theory or VBT. Okay, we'll be taking up these important topics in the upcoming lectures. So for this, thank you.